Hello everyone and welcome to this eCognition Deconstructed video. Today we're going to talk about the image object fusion algorithm. This actually has been sitting on the shelf for a few months or even years because I think it's difficult to explain, but I'm gonna try. So what does it do? It merges image objects based on rules, a so-called fitting function. So you can define rules when you allow to merge an object or to grow. And you can optimize the resulting objects based on the seed object, which would be more or less a merge region, or the candidate object, which would be a grow region. So we have algorithms for those two, merge region and grow region. And also based on a feature of the target object. So you can define or set up a rule that an object is only allowed to grow if the target object, so the final merged object, fulfills certain criteria. And you also can use combinations, and that makes it difficult, but if you understood it, it's highly helpful and it's a fascinating algorithm. Let's have a look at theory at the beginning. All right, I'm going to show you some examples in theory, and then we're going to have two projects actually. Terminology wise, the term seed is used for the current image object. So that's the seed, what is classified and that you want to grow, right? Or merge into neighborings. Then the neighboring image objects to this current image object, this seed, are called candidates. And we have also the term target, which is the final object that is merged based on the conditions that you define. And of course, you also can set a class filter to restrict the potential candidates by their classification. So not only the fitting function, but you also can work with classification. So what settings do you have for the fitting function, which is the core of this algorithm? You have the fitting mode, which is or can be all fitting, first fitting, best fitting, or best fitting if mutual, search mutual fitting. So different fitting modes that you can choose based on your needs. Then the fitting function, that's a feature you want to use to merge or to define this definition. Then the comparison, greater, less, equal to, whatever. Fitting threshold, that's the value that you want to use for the decision if you want to grow or not. And this fitting threshold is compared against the result of the weighted sum settings that you see below. And we're gonna have a look at this in a second. Use absolute fitting value, that's very important if you're looking for differences, for example, difference between seed and a candidate. If you set to yes, all differences become positive. If you leave it at no, you can have negative and positive differences. So if you're looking at differences, this setting is very important. And then we have the weighted sum. And this is actually the formula that computes a value which is compared against this fitting threshold. And the formula includes or can include the target object value, the seed object value, or the candidate object value, or any combination you can imagine. When to use it? I mean, it allows you to have full control of your merging and growing of your objects, right? You can define the fitting mode, the feature, how you want to compare those, a threshold, and then also what you want to compare, the seed, the candidate, the targets, and so on. If you don't need a fitting function, right, that is or can be complicated to set up, we do recommend to use merge region if this does the job, or grow region. Those are already existing algorithms that might do the job. But if you're reaching the limitations of those, then have a look at the image object fusion. Okay, let's have a quick example of what you can do. So you can optimize a seed object. So you can define a threshold that says, for example, look at my seed objects that are class A and only grow if this seed object has a certain value, right? So that would be optimize the seed object. Optimize the candidate object would be only grow into a candidate object if the candidate object fulfills a certain criteria. Optimize the target would be you tell the algorithm that it should grow and become the longest object possible based on all the candidates of a single object, of a single seed object. Okay. So for the fitting function, you can define 3 values: the target feature value, seed feature value, candidate feature value. And those can be used in combination. You can enter negative values, positive values, 0 values. And what you see on the right hand side are combinations that are used frequently. So 1, 0, 0, if you enter a 1 for the target feature value and 0s for the others, that will optimize the target object. 0, 1, 0 would be optimize the seed, 0, 0, 1 optimize the candidate, which would be grow region, and the previous one would be merge region. And 0, 1, minus 1 would be the difference between seed and candidate. Right? I'm going to show you theoretical examples now, and afterwards again 2 hands-on examples how you can implement that in your rule set. Okay, let's get your brain working. So on top in the table you see the different settings: fitting mode, fitting function, comparison, fitting threshold, use absolute fitting value. We're going to focus on the fitting mode. The fitting function doesn't matter, it's a feature, the comparison, and the fitting threshold. And again, we first going to start with this 100 combination to optimize target. Let's have a look at an example. On top right you see image objects, and the red one is our seed object, the blue ones are the candidates, and yellow finally will be our target object. We use best fitting greater than 1200. And if we now go through all the candidate objects, we can compute a value that comes out of this formula, which is target value times 1 plus the seed feature value times 0 plus the candidate feature value times 0. And that means we're only interested in the target feature value. And if this fulfills the criteria that we've defined in the fitting function, best fitting greater than 1200, it's gonna merge, but it's only looking at the best fitting. First, it checks this candidate. 500 is the candidate value, 1000 the seed. And if the objects are the same size, the target value would be 750. That means this wouldn't fulfill the fitting function criteria that we've defined, which is greater than 1200. So this one falls out of the equation. Now we're gonna have a look at the next object. That's the next one. You see the candidate value is higher, and if we fill this value into our formula, the result is 1125, and that also doesn't fulfill the criteria that we've defined for the fitting function. So we gray it out, have a look at the next one. Here we see the final value would be 1300. That's good. It's green, it fulfills our fitting function. And the next one, the candidate with the highest value, and the result would be of the target 2600, and that also fulfills our definition. But now the fitting mode comes into play. We chose best fitting. That means it fuses with the best fitting candidate. And if we change that, for example, to all fitting, it would merge both that fulfill the criteria. Best fitting only the best one, okay? Let's have a look at another combination of the weighted sums, in this case 0, 1, 0. So we're interested in the seed feature. If this fulfills the criteria, it's gonna fuse. Best fitting only gonna fuse the candidate with the highest value. And if you change it to all fitting, it's gonna merge into all surroundings if the seed fulfills the criteria. Now, next one, 0, 0, 1. This one is focusing on the candidate feature value. That means if the candidate fulfills the criteria, it's gonna merge into the candidate. In our case, the fitting threshold is 1500, so every candidate that has a lower value than this gonna be finally merged, because the fitting mode is also set to all fitting. It won't merge into those candidates that are higher than 1500, and that would be the 2 on the right. The final object would look like this. Let's have a look at another one. It becomes more complicated. The difference between seed and candidate, 0, 1, -1. That uses the difference between the seed object and the candidate, and that has to fulfill the fitting function. And if it fulfills, it's going to be merged because we chose fitting mode all fitting. So not the best fitting, it's going to choose all fitting. And again, it goes through all candidates, and what we have to change in the formula is the value of the candidate objects. That's going to give us a different results. If that is true, merge it. And that would be the final object out of this formula. And I think based on these theoretical examples, you see that the options are more or less endless, because you can change the weight of seed, target, or candidate. You can change the fitting function, the comparison, and so on. So options are endless, and that makes this algorithm very powerful, but also a bit more complex than other algorithms that we have. Let's have a look at two real-world examples. Let's have a look at this one. It's called Silo Extraction Project, where the idea is that you have, or you want to create very round objects, right, using the image object fusion. And I'm going to show you how to use the roundness of objects, right, to improve the segmentation. So any object feature can be used in the image object fusion algorithm. Gonna adjust quickly the stretch to standard deviation on both panes. We do have a small subset here, and I manually classified those just to show you how it could work. We do have two maps, map 1 or the main map and map 2 at the bottom, and I'm gonna work on map 2, so at the bottom here, and then you can compare the initial classification to the ones that I reworked with the image object fusion. Okay, let's have a look at the settings here. Image object fusion, class filter is silo, so that's the purple class here, and condition is area less than 200. So it only will use the image object fusion if the silo is smaller than 200 pixels. If this is true, grow or use this image object fusion algorithm. Loop it 5 times, so I'm trying, or the maximum number of loops is 5, so it's growing into the surroundings, or it can grow 5 times. And what do we have here? Fitting mode, best fitting. So it only uses the best fitting. As a feature, as a fitting function, I'm using roundness, so a geometry feature of the object itself. And comparison greater than 0. Now we have the target value factor is -1, seed value factor is 1, and candidate value factor is 0. That means it subtracts the target from the seed, which again means it, if you look at the fitting function, it only will execute this if the target is rounder than the seed. So only if that feature is improved here, which means only if the target object has a better or higher value in the roundness. So if the target is rounder, then grow into this object. And best fitting, only the best fitting, okay? Blah, blah, blah. Let's execute this one. And now we have to display the map 2 down here. And now, because we have the side-by-side view, we can zoom in and see on top the initial classification, and at the bottom this image object fusion that was looped 5 times and was improving the roundness of the object. And in this case, you see it added this object and this too, and then it was done, because adding this one wouldn't improve that roundness, okay? Same for this one, it added actually this object as well, and that one. And this one, 1, 2, 3, 4, 5. So actually we looped it only 5 times, so it wasn't able to add another one, even though it could have improved the roundness. Okay, all look good. Even this one here, which looked poor at the initial classification, now looks like a more realistic silo, I would say. Okay, but I've added another image object fusion because I saw the result were not that satisfying. And in the next one, I'm gonna fuse based on brightness. So if the difference of the seed compared to the target is low, then in brightness, then merge them. And again, as domain area less or equal to 200, again limiting the maximum size of a silo, number of cycles infinite, and again here best fitting using brightness comparison less than 10, -1 +1 0. So only fusing if the resulting target object doesn't have a very high difference in brightness compared to the seed. And I'm gonna execute this one, and you see those were growing, and now the silos look pretty convincing. And you can again use any feature, any image object feature that eCognition offers to define your fitting function. Well, let's have a look at the second project, this flat roofs project that you're also going to find in the data folder. If you don't see the results panel, this window up here, please go to View, Windows, Results Panel, and then also move it to this location and adjust the size, because the rule set's going to write information in there to inform you about the status of the rule set, so at which position it currently is processing wise. Let's have a look at the rule set. So we are looking at the image object fusion algorithm setup. Simply going to execute this one. This one's going to create an index layer, does a segmentation and so on. And actually the idea is to get nice outlines of the building. Most of you are probably using the multi-resolution segmentation to create objects. That's perfectly fine. But if you're looking for buildings, those objects do not really represent the buildings, right? So you could improve the segmentation. How could you do it? You could use the image object fusion, for example, and fuse objects that are similar to each other, right? That are representing buildings, and maybe you get better outlines of the buildings. So let's have a look and unfold this too. I do have quite a lot of things in there. Actually, you can ignore the results panel update during loop. That's gonna write information in the results panel while looping, while executing. And actually the only thing that we gonna check here is the image object fusion. So what are the settings? Class filter is set to active. That means it looks at the active image object. Gonna explain in a second what this does. Here, that's what we had a look at previously, the weighted sum, so 0, 1, -1, so it actually looks at the difference of the seed and the candidate. And the fitting function, that's the mean DSM, so it looks at difference of in elevation, comparison is less or equal to 5. So if the difference between the seed and the candidate is less than 5, in this case feet, then merge them and only merge the best fitting. So that's the idea, right? We want to merge image objects that have more or less the same height, so the maximum difference is -5. If this is the case, merge them together. And the idea is to get building outlines. Now, the candidate classes is urban. Actually, everything that you see here, these objects are classified as urban, and this is unclassified. So I did a pre-classification, and here in the image object domain, it takes the class active. Why does it take active? I created a loop here, and actually this loop is, I think it's fairly smart. What it does, it finds the domain extrema. That means it looks at all urban objects and starts or classifies the maximum in the mean DSM. So it actually classifies the highest object as active. And then it goes into that loop. It grows if it fulfills the condition, and afterwards it classifies the active back to building, and it loops again and then looks into urban and again takes the highest value in the DSM, loops the merge here, this image object fusion, and then continues. And it does that loop as long as we have objects classified as urban. So it takes from the urban, classifies the highest as active, then uses the image object fusion to grow the active. And if this is done, if it doesn't find any objects to fuse anymore, it classifies the active into building. And then it starts again. It looks into urban, classifies the highest in DSM into class active, does the fusion and so on. And what I'm using here is the results panel. So I'm updating here information on the classification. Going to see it in a second. And right, what I'm going to do is I'm going to set this to update view, this image object fusion. That means each time after it has executed this one, it will update the view, and that actually gonna help you understanding where the rule set is at the moment. It slows processing time down drastically. I'm gonna show you that as a comparison, but for demoing purposes, it's great. Let me quickly rearrange windows so you have a better experience watching this. Okay, and let's execute it. And you actually see what the update view does. It updates the view, and then you see how it looks like after a building was created. And in the results panel, you see the number of buildings. So it ran through the loop already 150 times, and the leftover urban objects that are all going to be used in this loop, because we're looping until all urban objects are reclassified into the class buildings. And what you see is that we get nice outlines of the buildings, or better outlines than before, based on image object fusion and fusing if the difference in the elevation is low. That works great if you do have flat roofs, right? For gable roofs, yeah, the idea is not that good. But if you have flat roofs, you can run this and you're gonna get good results. We are actually using a difference of 5. You could reduce it, so you're gonna get more building objects, or you could increase it. And I mean, the result's not gonna be perfect, but you could rework the objects afterwards and kick out small objects, use remove objects and stuff like that. But it shows you how you can improve image object outlines based on image object fusion. Good, so it's done. I also write down at the end in the current status in the results panel the start and finish time of the loop. So you see it actually 24. Yeah, it took more than 2 minutes. You also see it in the rule set. And it took that long because we are using this update view. But now we have nice image objects that nicely delineate buildings with different heights, or it delineates them better, I would say. I'm quickly gonna remove the update view and run it again, so you see that the update view consumes a lot of resources. Let's run it again. So it took 2 minutes, and now you also see the numbers are going down way faster. Done. So 5 seconds. So only use the update view if you really want to see what's going on and understand the impacts of this setting. Okay, that was it. I recommend rewatch this video because it was quite intense and a lot of information. Try to use it. That's the best way actually, I think, to learn how this algorithm works. Have an example, try to play around with the settings and see what is changing and how it impacts the final fusion. Implement it in your projects, enjoy using it, and thank you for watching. See you next time.